to the internet. I'm sure you're used to this, which is a RJ45 wired connection, or one of these, a tablet, which connects wirelessly to the internet. Less people will be using this. This is fibre optic cable, a high-speed internet service, which works completely differently to what you may think. Now, we have to actually go into quantum physics to understand how these actually work, because wireless and fibre are quite similar, whereas copper wire through your telephone lines or cable providers are more mechanical. As you've just seen in the B-roll, I've just explained to you there is a difference, there is a dangerous difference obviously, in fibre cables, copper cables and wireless signals. Now, to understand the fundamentals of how a signal is transmitted, we have to go down to physics. Now, I'm going to impose over what's called a wave. Now, a wave is how things are transmitted, because we think of our world slightly differently than in actual fact what it actually is. So solids, gases and liquid forms are a basic of science and something that you should understand anyway. So the waveform which I'm going to impose over, or is imposed over, will show this oscillation pattern, and the wave goes both positive and negative. In computer senses, this is a 0 and a 1, so that becomes binary, and actually is the data that we're actually interested in, because it is how that works that gives us our communication ability. So when we look at a copper cable, the mechanics are the same as electron transfers, so therefore that is why I've said it is a electronic mechanical connection type, because you charge a electron which is passed to another electron and to another electron until it gets to the other end of the cable. This is about 767 miles per hour. On the other side, light, or on off, is still zeros and ones. So therefore, as I haven't got a card out, as light is fired down one end at 760 million miles per hour plus, the opposite end of the cable detects the light and therefore becomes a 1 or 0. Back in the olden days, and I'm sure everyone can remember, and I should really have pulled one up, which was a modem connection. Now, you dialed into the internet over your telephone line and you heard some squealy noise, and maybe we can produce some of that now. That noise is the binary data being transferred in an audible signal. So you have a audible signal, a light signal and a mechanical electronic signal. When you search the internet, do you Google the internet? And when you connect your mobile phone or your tablet or laptops, do you connect to Wi-Fi? This is a false concept in respect of what you're actually doing. Now, connecting, obviously when you're searching the internet, you're just searching the internet, a provider is Google, but it's become synonymous that Google searches the web as it is for wireless connection being Wi-Fi. Wi-Fi is one standard. It's a cheap, cost-effective standard which has been adopted and taken over, the same as what Google is for searching. So taking apart the two and taking away all the systematic complacency, wireless internet transport and connections, or wireless access services, or WISP, WI, has been around for decades, going back until the 1990s. Prior to this, there was transmission of data using radio signals, so FM, signal radio, AM, FM, telegraph, Morse code, the Marconi and Hertz, who invented and discovered radio frequencies wirelessly transmitted. You'll probably be more well versed in knowing that a radio that is in your car, the transmission from a base station, and it plays you back what's being transmitted. There is no difference between wireless, TV broadcast, radio broadcast and the service provided. All you are getting is a send, a receive, modulators or translators as to what each of those signals represents, as it's a 0 or 1 or otherwise, that will produce the sound or data that's on the other end. So once you get past the concepts of what was or what is, you have to look back at the physical sense of things. So even if you're connecting via your mobile data or your Wi-Fi connection, you're actually connecting using a very, very specific service. Now, when Wi-Fi came out or was available and conceived, it was a cheaper option that was a leading role. The same as if you're old enough, VHS and Betamax. Now, Betamax was better than VHS, but VHS was cheaper, therefore went forward, and Betamax didn't. We are quite aware now in the home domestic world of a 2.5 gigahertz wireless connection. There's also a 5 gigahertz wireless connection which has been round roughly for the same time. The 5 gigahertz connection was always assigned to more business use, and there's the 3.7s, the 5s to 10s and the 10s to 20s. Now all these ranges are bandwidth where things transmit. Now where I talk about light transmission and mechanical transmission, when your Wi-Fi signal doesn't work, it's due to the fact that the signal itself cannot pass through the material that's stopping it. Now you have to take signals in a slightly different way. Now we're probably well versed with someone who can sing at a specific pitch and break glass windows. Well, radio signals are exactly the same principle. So what we have is a signal at a certain level or oscillation and wave will pass through certain objects or go longer distances because the air that we're actually in is not nothing. It is actually something, and it is actually quite thick. The higher you go, if you've been up a mountain, you will know that the air becomes thinner, it's harder to breathe, and you probably need oxygen with you. Now the oxygen that we breathe and the different levels are quite different to sending a signal through the air where we may have rain, trees and other obstacles such as walls, windows, etc. that will break our signal or slow it down. Now the problem with signals that do not pass through is this signal that bounces. Because if you have a bouncing signal, as it hits something it adds a delay, and as it bounces to and fro, these delays become uncoordinated. So if you have a one signal that goes directly straight to you, but you have one that goes back, there will be two signals arriving which are the same signal but at different times, and this causes a problem. This is called signal echo. Now the technology brought out in 2003 was Mimo. Yes, Mimo. It's a really stupid name, but it's just multiple in, multiple out. And you probably have seen routers or routers dotted around with multiple antennae. Now these multiple antennae are advertised as some special magical form of witchcraft, but they're not. All they are is to collect the data signals and to send out the data signals from multiple points and receive them from multiple points. The routers themselves create the packets, rearrange the timelines and put them together. It makes it a slightly slower internet, but if you've got a bandwidth on a signal of say 5 megahertz, then 4 times that allows you to transmit 4 times 5 megahertz of data across the network. Thus, it speeds your internet. So now that we've done the Mimo, we have to look at Wi-Fi. Now, wireless connections and how that came about actually relates down to a system called WiMAX. Now, WiMAX is not largely used and has been commercialized because of capitalism and profiting. WiMAX is a very big serviceable network system and standard which actually produces huge, vast differences to the domestic rubbish and WiMAX is quite significant in that it is a wide network with wide bandwidth and superior services. WiMAX has been always toned down, never taken up because of profiting from lower grade services, because of the costs being lower and the service being something that was new and amazing. So basically what they've done is they've done it again where they have a brilliant technology, made something crap out of it, and over time upgraded the crap to what they had anyway, and every time selling something new to the customers. Now WiMAX covers between 5 and 30 miles, and I mean square miles. Well, actually it goes up to something like 30,000 square miles, one wireless router. So you have to think to yourself, when you're there and everyone's selling you a Wi-Fi connection that will always be around your home, and superior this and brilliant that and faster speeds this, utter rubbish. They are selling you rubbish, they have been selling you rubbish, and they've been selling you short. Now the Wi-Fi system in WiMAX offers wider bandwidth for faster transports, and you'll probably know it as what is being sold to you relatively as LTE, or 3G, 4G and 5G. That is part of WiMAX and a wireless technology which is exactly the same as your home Wi-Fi. So when you consider what is available to you when you're setting up a WISP and a backhaul, is in fact the problems you will get because of perhaps not knowing entirely what is available, what is the technology and what was the technology, and all the marketing rubbish and holding back on technology as probably the most best way to explain it. So if you're setting up your wireless connection and service, you need to think about what you are doing. Connecting 5 million users to your account at £1 will give you £5 million, but your internet won't work and you will soon lose your customers. I won't mention Virgin in any of this at all. So what I need to do then is explain to you that your service provisions require a backhaul. Therefore you must have sufficient bandwidth between your internet, as in the wider network, and your intranet, which I'm going to say is the wireless service, the WISP provision, because there is a difference between servicing a client and offering services. No innuendo intended. Now the process of this is rather simple. And I'm going to pause the video here because I'm actually going to get some tech, and I'll show you with some tech. Okay, so here's some tech. This, as many of you may know what one of these are, is just a big version of your home router. As you can see here, there are 2 ports, and as you can see here, there are lots of ports. Each of these ports are 100 megabytes. Each of these ports are 1,000 megabytes. So we have to do maths. If I have 2,000 divided by these ports, which are, I believe, 26 ports, yes, so 24 ports. 24, it's 2,000 divided by 24. So let's say, for example, there's 10 ports. And this is one port of 1,000. For every 1,000 I put in, I can get 10 lots of 100 out. That's called maths. Now, when we're sold our internet connections or our data or our hard drives or anything else like that, we are given fictitious fantasy numbers. So 8 bits make 1 byte. But we will be told that 1,000 bits make 1 byte or a megabyte, and we will lap it up because we are naive. So what do we do? Well, you cannot have 10 100s on 1,000 because there's an overhead to the network and packet scheduling and various other things which will automatically take off straight away 20%. We also need to consider the on-time usage. Now this may sound a little bit weird, but on-time usage or concurrent connection really does make a difference between how your network works and doesn't. America Online was a dial-up system service that, back in the olden days. What they used to do was have oversubscribed systems, and it would constantly cut people off so that it could connect another person to the internet. Now this works in various ways, such as the not mentioning Virgin crash, where their system was overloaded through a single point of failure, and that I told them 6 weeks before it would fail that it would. Now what people are trying to do, or the companies are trying to do, is maximise money and maximise profit. That's what companies do. We live in a capitalist society. So what we need to do is go, well, actually, ethically and morally, we need to be able to provide what we can sell to somebody, not fantasy it up out of some magic or discontent for other people. And by that I mean by going, yes, look at me, I have a 50 million gigabit connection, which you can all use. I'm going to sell it to 56 million people, and you'll all get 1 meg. That is basically how most of the service providers work. However, there is risk, load management considerations and concurrent connection considerations, all which are centered around exactly the same thing. What we do is we have a connection service, we have a broadband transmission service, and we have our end users. So that we can supply all our end users, we need to do maths in relation to how much do we need. Now typically there is peak and off-peak times, and I'm sure we can summarise some sort of thing that a person at work all day, returning home at 6 o'clock, will go on the internet from 6 o'clock onwards. They might miss it because Emmerdale or neighbours or a student that has to do homework, or a person that has to look after children, or such and such like, which is called a life dynamic. Now in those life dynamics, people won't be using the internet, so therefore you won't have a connection. However, life dynamics are not exactly the same for everybody, so therefore there will be people who are working shift patterns. So your daytime workers and your nighttime workers may use the internet at a completely different time. So therefore, can you double up your provisions for those users? Well, the short answer is yes, you can. But the thing is, you have to consider what is your peak load. Now, being able to provide a peak load at a reasonable speed is actually key. If you have a 1000-bit connection and you have a peak load of 2000, the concurrent split second or nanoseconds that your internet connection is passing packets through is down to the speed of the network and actually the speed of the internet service, both from you and their service provider or website which they are going to. So you can calculate that between what you are using, your customer base, and the speeds that you're expecting to give, that A, you can oversell to a degree, and that because of concurrent connections that there won't be an immediate connection between two people at the same nanoseconds. That's the difference between clicking a mouse. So if a person is online and they click, then they are, once they've clicked and their page has been loaded, that's their connection ended. So the next person can click, and so on and so forth. What the problem is when there are so many people with big bandwidth hogging apps or websites, then you are always going to get the problem of the much needed bandwidth. Therefore it reduces down considerably the service that you can provide. Now the internet, as you may know, is one of those things which has grown over time. Now back in the day, you could always connect up with your mobile phone, which was a Java based on a tiny little screen, and you could search the internet and send and receive emails. In the 2000s, you could use your XP machine or your Windows 98 to view very basic websites under hypertext markup languages, PHPs, and SQL Server database driven. YouTube was still around, although you had lesser quality than more quality, although this was an option you could select. However, you were normally limited by your bandwidth consumption, therefore you went for the lower qualities because it was quicker, it was cheaper, and it saved bandwidth. So how does bandwidth affect your use now? Well, unfortunately, upload and download speeds are not equal. So a server that's providing a 2 megabit a second connection will cause a delay when it's trying to load 10 megabits, 40 megabits, or even gigabits of data. That means that that route on which that connection is taken will take up all of your bandwidth until such a time as it's finished. However, that said, if it's such a low degraded signal, say 2.5 megs over 100 meg, you have all the rest of that bandwidth which can transport data. Again, this then relates to how many people will you have on your network downloading that same data, using this, causing the same issues of slowing down your network. So the solution is backhaul load balancing and caching. 3 simple systems which ups the production of the availability across your network and thus lowers your bandwidth consumptions and your service requirements to be able to serve your customers. It's not difficult to do and is pretty much automated in most systems. In 2006, when we first looked at GWISP, we looked at compression. Now compression was or is a compressed file, because some things over the internet are not compressed and could be squashed down to all the free space that's in them. Therefore you are compressing your data, it's taken, it's sent then and decompressed. Oddly enough, when companies were limiting and charging for the amount of data, no compression was used on their networks to maximise their profits. So how do you do it and what do you need? Well, we're going to go through some technical drawings that I'm going to do, which are very technical, nicking the kids' felt tips and writing on a bit of paper. You need to understand first of all the mesh of a network. Meshing a network is the interconnection between all of its parts. Nodes and other connection types are probably going to be one of the main factors in the availability and access of your network and your customer satisfaction. You don't want to be like any of the other providers who go through certain routes which have single points of failures to vast amounts of customers. You can get away with it because you're not going to be stupid, and you have my brilliant guidance which will probably assist you and get you out of more trouble than what you will stumble into if you were to do it alone. However, there is some semantics on it, and I am probably being a little bit over optimistic because you will probably get problems, as everyone will do. It's just a matter of can you manage it or not. So when we look at the network requirements and the infrastructure, we must take into very good consideration what the customer expects and what you can actually provide. See, if you provide a decent system or service to somebody and it is at a certain price with certain limitations, pros and cons, and that's known to somebody, a person's less likely to complain, although there are certain people out there who are just born complainers. So what you will do is you will satisfy a customer and you won't let them down, and you will not fail if you provide them with the correct information, all the information and accurate information all at the same time. It's just a matter of going, well, how can I do it? What is it? And should I underestimate it? Therefore, everything is better. Now, with the network system that we used, we could do 145 megabits per second. That equates out to actually near 300 megabits, which is the common one that's advertised, although we knew that it was going to be at least 10 megabits slower. So when you think about what internet speed you're going to offer, the maximum you should be looking at is probably around 30 to 40 megs a second. That's probably all you're going to get, because there's going to be problems with what you can actually do and provide. The further a customer is away, the slower the speed is actually going to be, but you have to consider latency in that transporting of the signal and data to and fro. There are ways around it, and that goes on to load balancing and routing. There's also the compression. If you add too much compression, you will cause more delay and latency, although you will be sending over huge chunks of data. However, from your point of view, you want to be caching the data so that you're not downloading it, so your main pipe is not blocked with downloading the same contents over and over again. Now, for a typical example of this, Windows Update. If you've got Windows 10 Update and you have 100,000 customers on Windows, you want that Windows Update not from Microsoft but from your own local server. This then stops your system trying to take internet information from a slow server or other servers from around the world and puts it on a local internet. So if you have a local internet connection, and your ISPs do this to some degree, your local connection will provide the higher speeds. Therefore, the time spent in using the bandwidth is therefore significantly reduced, and therefore you can benefit from that. But the same goes for other things as well. Now the problem is that I've just done a 65 gig download from a game. Now that took quite a while, but I could have cached it and therefore I wouldn't be using bandwidth. And anyone else, if they had the same game on their computer here, could have gone on to there where I've downloaded it and saved it locally and taken it locally. So they would have had up to 4 gigs transfer speed, whereas I had to put up with 2.12 megabits per second, and that was horrendously slow and time consuming. So as you can see, there's a difference between how the network works, where you load balance and where you put things. that really does impact on the overall efficiency of the network. So once you get past of how you're going to transmit everything, how you can load everything, latency issues, and the difference between Wi-Fi, wireless, and WiMAX, that they're all exactly the same thing, but just marketed differently, just for profit, then you can start looking at what way can you provide a network service and how to consider customers, and this goes then into business analysis. Now, luckily enough, I'm a qualified business analyst and I'm approved by the departments in the UK government.